So, welcome back. Today again we will be talking about various assessment of physical and cognitive work with psychophysical method. Last class we discussed about what are the varieties available, and one of them we discussed, that was the EMG. So, in this class we will be talking about EEG, ECG and eye tracking, and rest few, as we do not have the instrument at our laboratory. So, we will not be able to give it in detail, but of course, if you have queries you can refer back and then we will be able to solve your query. So, let us start about ECG. Okay. So, what it is? As in last class we understood that EMG is electromyocardiogram. So, ECG is electrocardiography or electrocardiogram, right. So, what it is? It is related to your heart activity. So, when somebody is working, so physically active, the heart actually pumps, right. So, blood comes in and goes out, and the whole circulation keeps on going. So, how that activity of heart muscles can be recorded in terms of electrical potential difference, and then how we can interpret the physical exertion, mental load and all those things. Today we will be discussing about that. So, let us understand what it is. So, when any cardiac impulses passes through the heart, electrical current also spreads from heart into the adjacent tissues, or we can call it the surrounding heart. So, a small portion of the current spreads all the way to the surface of the body. So, if electrodes are placed on the skin on the opposite sides of the heart, that electrical potential generated by the current, it can be recorded, and this particular recording we will be calling as electrocardiogram. So, let us understand how this electrocardiogram looks like. Okay. So, many of our parents, or many times we have seen ECG recording, ECG data, right, but we never thought of looking at it and let us understand what it says or how the doctor actually interpret this data. So, let us understand few components of it, so that when you are going to record or when you are going to see that particular recording or that printed copy, you may understand or you may analyze or interpret few parts of it. Of course, medical analysis is different as compared to the kind of analysis or kind of interpretation an ergonomist look for. So, that is very different, but still few components are common. So, let us understand major visible components of ECG, and let us understand what does it mean. So, whenever we are talking about ECG recording or electrocardiogram, there are few waves that we are going to see, or it is visible in that particular page. First is P wave, then is QRS complex, and then third is T wave. So, the whole one cycle consists of P wave, QRS complex and T wave. But many times it happens that this QRS complex consists of three separate, that Q, R and S wave. Sometimes there are changes. So, these changes only we need to identify and we need to interpret our results. So, the electrical potential which generated when the atria depolarize before atrial contraction begins, that leads to generation of the P wave. So, this particular P wave is a depolarization wave. So, why it happens? Before the atria contracts, there is a depolarization. Okay. So, when this depolarization happens, then this P wave, actually that P wave comes. Then if we are talking about the QRS complex, it is about the ventricle. So, QRS complex is originated by the potential generated when the ventricles are depolarized before contraction. So, both P waves and QRS complex are because of depolarization. So, we call these all three as depolarization wave, whereas T wave is something different. So, when the potential generated as the ventricles recovered from the state of depolarization, so it is repolarization. So, that creates the T wave, and this particular T wave process continues for 0.25 to 0.35 seconds. It is because of repolarization we call this T wave as the repolarization wave. So, the electrocardiogram is composed of both depolarization and repolarization wave. The distinctive properties of depolarization and repolarization waves are very important when we are talking or interpreting the ECG recording. So, if there is a changes in this particular process, that the speed, the amount of time taken, or the amplitude is expected, or the positioning of this depolarization and repolarization. So, P, QRS and T components, if there are changes, then only there is a concern, and we really need to understand that, and we need to interpret. So, before I go for analyzing that data, let us understand how we are going to collect the ECG recording. Okay. So, when we are talking about ECG recording, very important aspect is to understand what is bipolar lead. So, what we do is that ECG we normally record from two particular electrodes, which is located two sides of the heart. Okay. So, in this case normally two limbs, either two hands, two hand or leg, like that. So, it is two limbs, because it involves two limbs, we call it bipolar or bipolar limb leads. Okay. So, there are three types of leads we have: lead 1, lead 2 and lead 3. So, what this lead 1 says? It is a negative terminal of ECG which is connected to the right arm and the positive terminal of the left arm. Lead 3 is the negative terminal of ECG is connected with the right arm and positive term of the left leg, not left arm, left leg. Whereas lead 3 is the negative terminal of ECG is connected to the left arm and the positive terminal of the left leg. So, this way all these three leads are connected and we place our leads. Okay. So, once we place these three leads, what happen? There is a triangle formation. Okay. So, kind of this type of triangles actually forms. What it means? It has a particular terminology we call this Ithoven's angle. So, the two arms and the left leg forms an apex of a particular triangle which surrounds the heart. So, heart is here, it is located like this and there is a triangle. So, this particular triangle we call it as Ithoven's triangle, and it has a very specific nature. So, we will understand that. So, the two apex of the upper part of the triangle represents the points at which the two arms connect electrically with the fluids surrounding the heart. Okay. And the lower apex is the point at which the left leg connects with the particular fluid. So, what it says? It has a particular law. So each this limb has positive and negative values, right. So, if the electrical potential of any two of these three bipolar limb electrocardiographic leads are known at any given instant, the third one can be determined mathematically only by summing up these other two. Here consideration of sign like positive and negative is very important. When we consider not only the mode value with sign like plus this volt minus this volt, if we can simply plus them like add them, then we will get the third one. So, that is the rule we have in this Ithovan's triangle. So, this is the law we follow when we are talking about the ECG recording. So, when we are doing the ECG recording, it is very important first to calibrate the whole system and to understand when the recording is happening, how the voltage is getting measured. The horizontal calibration line what we have in the graph are arranged in such a way that the graph paper, in that particular graph paper, 10 small line division represents 1 millivolt. Okay. There are small graph. I will show you in the next this particular figure how to calculate it. So, 10 small line divisions represents 1 millivolt. So, positivity, it denotes upward movement, if it is negative then downward movement. So, time calibration is achieved through horizontal lines where each inch represents 1 seconds. So, each inch is generally divided into 5 segments by dark vertical lines. The interval of these are actually being 0.20 seconds. This is further subdivided into 5 smaller segments by thin lines and interval is 0.04 seconds. So, what you can do as soon as you finish this class, you go and pick up any ECG recording plate like whatever is available with you and try to understand how these lines means and how you can identify these values. Okay. So, then only you will be able to, you will start interpreting your own data. So, this is normally a common ECG graph looks like. So, this is like P, Q, R, then comes down S and then it goes here as T. So, this PQRS component. Okay. So, here if you see this is the time and here is the millivolt. Okay. So, this is the, here you can see the kind of electrical potential is generated in the time slot. So, here you can see I have mentioned PR interval, then RR interval, PR interval, QT interval. What does it mean and what it actually depicts and how we are going to understand that and how, what is the meaning of this. So, that I am going to tell you in next few slides. So, let us understand first the normal voltage and then how the other when there is a discrepancy, how we are going to understand it. So, depends on the manner in which the electrodes are applied to the surface of the body and the distance of the electrodes from the heart, we have different recording. So, each QRS complex usually have 1 to 1.5 millivolt from the top of the R wave to the bottom of the S wave. So, this is the recording if it is normal. Your heart function, if it is normal, then we will get this recording. For P recording, P wave, it is 0.1 to 0.3 millivolt, whereas for T it is 0.2 to 0.3 millivolt. So, this is the normal range. So, if there is any changes, then we have a concern, we have a consideration that what is the problem and where the problem is, why these changes are happening, and then we will inquire it back. Okay. So, what is PQ or PR interval means? So, it is a time from the beginning of the P wave to the beginning of the QRS complex. So, many times it happens Q wave is missing. So, sometimes we call it PQ interval or sometimes we call it PR interval because many times Q is absent. So, normally this particular value stands for 0.16 second. So, if there is change, please look at why this change is. Some, as I mentioned, as Q is absent many times, we call it PR interval as well. Now, QT interval. So, this is the time of ventricular contraction. So, when ventricle contract So, that is the time like after depolarization, that repolarization happens. So, the contraction starts from the beginning of the Q wave and lasts till the end of the T wave. So, ventricle contracts and then finally it is relaxed. So, the normal value of this total range, like I will tell you total range. So, from here to here. So, this peak, okay, this peak. So, we call it as QT interval and this is approximately around 0.35 seconds. Now, from the ECG recording, how we are going to determine the working heart rate, or if the patient is in a resting condition, how we are going to determine the resting heart rate. It is basically the one cycle, distance between one cycle to another cycle. Take an example, if the whole complex, like the whole cycle completes in 1 second, then your heartbeat will be 60 beats per minute, because each second 1 beat, 1 PQRST complex, the whole thing, right. But if that changes, like QRS, the two successive QRS has the interval around 0.83 seconds, then that is your normal heartbeat, that is 72 beats per minute. So, 60 divided by 0.083, it comes around 72. So, 72 beats per minute is normal heart rate. So, when you are reading any ECG recording or ECG graph, you measure the distance between one QRS to another QRS, that particular state, then you see what is the amount of time taken for that. If it is 0.83, then your heartbeat is 72 beats per minute. If it is more or less, accordingly you can calculate it, 60 divided by that amount. Okay. So, then you will get the heart rate. So, if you are an athlete or you are physically very active, your cardiac capacity is very good, then maybe your heart rate can be little on the lower side. Okay. But if you are in a panic condition, if you have done some physical activity, then this particular distance of successive 2 QRS will reduce and your heart rate will go high. So, that is the kind of interpretation you can do from by reading the ECG recording. So, the overall time of different components, that is PQ interval or Q2 interval, QT interval, and the deviation from the normal values what I mentioned earlier indicates the presence of cardiac arrhythmia. Okay. It can be bradycardia, it can be tachycardia or any other cardiac problem. However, for more detailed and specific diagnosis, the 3 lead data like lead 1, lead 2, lead 3 we should read separately, and each lead data can give different aspect of your ECG recording. So, if you get some problem or some discrepancy in the normal one, you will read it separately and then you will find out what the problem is in actual. Some very specific commonly identified features that I try to jot down here, I will tell you. So, if the ECG what you recorded has the recorded from any tachycardia patient. So, what will happen? The 2 successive QRS complex, the distance will be little less, whereas for the bradycardia it will be little more, means your heart rate is less. So, for sinoatrial block, the rate of QRST complex is slowed down and there is a sudden cessation of P wave. So, that also is can be seen. For first degree atrioventricular block, prolonged PR interval that may you find specifically from lead 2. For second degree atrial blocks, there is a sudden drop beats, that means there will be atrial P waves, but no QRST complex. Okay. So, if that kind of phenomena you see from the lead 3, then you can say it is a second degree of atrial blocks. So, these are the indications. Also, if you find some abnormal voltage in QRS complex, you can identify there is a hypertrophy of the muscles, stenoic pulmonary valve, high blood pressure, etc. if the voltage is increased. If it is decreased, then you can say pericardium, pulmonary emphysema, or any similar type of disorders. So, abnormally shaped and prolonged QRS complex can be caused by cardiac hypertrophy, dilation, etc. Here one important thing is how T wave looks. T wave is on the positive side, but if somehow you find an inverted T wave, like it is on the opposite direction, then you can expect a mild ischemia at the apex of the heart. Biphasic T wave also sometimes is visible, and it can be caused by digitalis toxicity. So, that is also possible. For ventricular fibrillation, ECG becomes bizarre and it shows no particular pattern. So, that is an indication when especially you are doing lot of cardiac test, right, okay, stress test. So, if you have such kind of indication, you really need to go for medical intervention. So, that is important. So, whatever we spoke till now is lot of medical aspect or medical understanding of your ECG. But how these things are important for an ergonomic assessment or ergonomic workplace analysis system, that we need to understand. So, when we are talking about work or work related stress, it is very much related to your physical stress, right. So, and which is directly dependent or can be reflected on the heart rate or heart activity or cardiac activity. So, if the person is physically active, so you can really directly monitor that one through the ECG recording. So, that is objectively you can measure and you can find it out. Whereas, if there is mental workload where the person is in sedentary position, but lot of mental stress is there, that also sometimes can be reflected from the heart rate recording or not ECG recording, not heart rate recording, ECG recording. Okay. So, these are the major application of ECG when we are talking about implementation of ECG recording or ECG data or including the ECG analysis for your ergonomic studies. Okay. So, here what I would like to say is whenever you are planning something related to identifying the physical workload, especially physical ergonomics, and a lot of manual activity, lot of mental stress, there you may plan for this type of study, and you can record ECG and you can analyze it. So, today's task will be you just pick up one single ECG recorded paper which is available nearby, and then you really count them in millivolts and along with the time, and try to interpret how the data is and what is the condition of that particular heart. Okay. So, if you have any difficulties, please contact back, and so that we can also assist you for your better understanding. So, once ECG is done, I will take you for another important kind of psychophysical analysis, that is the electroencephalogram, okay, or we can call it EEG. By nomenclature itself, we understand it is related to related with your brain, right. So, when there is a brain and it is in living condition, always there is some electrical action potential is getting generated, and it has a very specific pattern. Okay. So, always it is available, and some kind of electrical activity is there, and once we record that activity we call it EEG recording or electroencephalogram we call it. So, there are two very specific post synaptic potentials, one is excitatory, another is inhibitory. So, once we record these excitatory and inhibitory post synaptic potentials, we sum them up and we get the EEG recording. So, how this EEG recording is and what the meaning of all this, let us understand. So, EEG display the graphs, it shows in voltage on the vertical domain, same as your ECG, and time on the horizontal. Okay. So, here if our graph is there, so in this case it is voltage and here it will be the time. Okay. So, same as we have in ECG and even in EMG. So, with digital recording and we have lot of instruments, technology, what we get is the EEG display which can be modified for ease of our use and a lot of interpretation. So, it is possible sometimes to adjust the sensitivity of the recording in microvolts per millimeter to either increase or reduce the display height of the waveform. Whatever the waves we are getting, we can adjust that. So, this amount of time displayed may also be altered, can possible. So, this is referred as an the epoch potential we call it, and used to be known as paper speed. So, that is possible. So, shorter the intervals can be viewed with a few seconds on a computer scene, and this is the advantages for viewing very brief EEG event. So, if it is very brief, then we really can capture that one in computer and we can really see it. The time scale may be expanded to display the largest segment of EEG over several minutes to observe for those phenomena. So, digital filters also we can use, and we can reduce the artifact for certain settings, and whenever actually you are going to use EEG or you are going to record EEG, then you will be understand how to do these small adjustment. Now, here again I would like to mention, as I mentioned in my previous class, that EMG recording, preparation of the of skin or placing of the placing the electrodes, all are very much skill based. So, as many times you will be experimenting, you will have more confidence and you will be more clean to do this particular job. So, it is very important you keep on practicing this type of data collection and instrument handling, same as for your ECG, here also for EEG recording. It is very important. It is very much experience dependence. The first time when you are going to record, you may fail to understand or fail to gather a proper data, but if you continue it for several experiments, you will be master of it. So, that is very important for all this type of recording. So, as in the we are talking about the action potential and its differential potential, it is very important to amplify it. So, same as for EMG, the nature is same, but the instrument used is little different. We actually what we does it the same principle, the differential amplification. Okay. So, that only we use for the EEG signal processing. When we record any EEG signal, we have some very specific type of waves that actually helps us to understand that what is the status of our brain. We have beta, alpha, theta and delta. Okay. These are the major 4 types of waves we see from the EEG recording. So, these are the hertz that represents these specific types of wave. Now, let us understand what these waves represents. Okay. So, alpha says when you are in a awake condition, but you are not focused, okay, you are little relaxed, you are drowsy, your eyes are open, but you are not really looking at something, okay, then it is alpha. Whereas, beta is very much alert awake condition. So, you are doing some focused problem solving, you are in dream, but in REM sleep, okay, high environmental stimulation. So, in these cases you will get beta wave. In theta, if you have some visual imagery, light sleep, then you will get theta wave from your EEG recording, and delta when it is in deep sleep and vague dream status, then you will get all these waves. So, normally when the person is like working somewhere, either alpha or beta, there are probability is there to gather this type of these two types of waves. So, when somebody is working, what is the type of concentration we need, based on this value or this type of wave recording, we can understand that. Okay. As in EMG also we had so many varieties of artifact, same here in EEG we have artifacts like eye movement, tug movement, talking, chewing, movement artifacts, electrode artifacts, sweat artifacts, all these are there. So, you really need to bother, or you really need to understand how to eliminate them and how to get correct data. Okay. So, let us come for the recording, how we are going to collect this type of EEG recording. As I mentioned in the beginning itself, it is a differential potential. So, of course, you have to record this particular process through a kind of electrodes. You have to place it in throughout your skull, and then you have to record the kind of movement is happening. Okay. So, before the skull is ready for data collection or ready for placing the lead, you need to really remove the hair, some kind of light abrasion is required, which will actually help to reduce the impedance due to dead skin scale, same as for your EMG. Nowadays, lot of advanced systems are available where electrodes is attached to an individual particular wear and you connect it directly. In some system you have a cap where electrodes are placed beforehand and you are just putting that cap on the head of the person and then you start recording. So, these are the modification or very advanced instruments available where you can gather the data. So, see, for EMG we have very specific requirement, like which muscle we do not know, it is absolutely based on the researcher. We need to find out that particular muscle, belly of that particular identified muscle. So, it is very dependent on the researcher, but in case of EEG you have approximately pre-identified location because we are going to put on head, right. So, these type of caps are available, so you can directly use them. Here one principle or we can say international law we have, that is 10-20 system. What does this particular mean? So, it says the intervals, the standard intervals of measurement of either 10 or 20% of for the positioning electrodes over the anterior posterior dimension between the nasion, okay, this location. So, point at the bridge of the nose and the inion, that is the prominent bump of the back of your head, or that is the skull, and the between the auriculum, that is the ear position. So, here, okay. So, this way you need to place your electrodes. Now, each electrode site is represented with a particular letter which is given a number, like if you are putting any electrode that is in the frontal lobe, that will be denominated as F, temporal T, parietal P, occipital O. So, this way you can give the nomenclature of your electrode. So, it is rule that odd numbered electrode sites are on the left side of your head, whereas even number is on the right side of your head. So, that is the rule. Now, once you start recording this type of like this EEG, so each electrode is connected to one input of differential amplifier, and a particular common system reference electrode is connected to the other output of the differential amplifier. So, that is standard. So, in analog EEG, the signal is getting filtered once it get recorded. That EEG signal is then recorded as the pens are moved on a particular paper, like it is a kind of rotating ball. So, paper is moving and there is a pen which is getting recorded. So, it records it, right. Same we measure, we get the cardiogram in a moving paper, like same smoked paper sometimes, in that way, similar fashion. Okay. So, how brain activity happens, needle moves and it keeps on recording. So, that is the way we should record it. Now, once we record all these EEG value, like alpha wave we have seen, or we see the beta wave, or somebody is sleeping, we are getting some other wave. What we are going to do with this data? We really try to interpret this particular data based on the kind of mental status we have in that particular situation. Suppose a person is working in a particular workstation or workplace, there is some occupational stress in terms of psychological or in terms of peer understanding or supervisor pressure. How that is getting activated, because see, all this stress has an impact on your performance. So, if you really do not understand the mental status or mental health of that particular worker, you will not be able to really interpret. So, questionnaire is a method to understand from the person's perspective, but actually what is happening you do not know. So, being an ergonomist, if you interpret these EEG data, you will be able to understand the brain activity and their responses at work or job or at a particular task. This is also very important when we are talking about design. Now, let us take example, we have designed a product. How the operation of the product, function of that product or aesthetic of that product, how it is impacting on the human brain, how it is interacting, the human being is interacting with that particular product, or you are looking at an web page, how the information is getting focused, how you are trying to understand that. All these aspects are very important for the designer to know. So, there we can definitely use EEG recording and EEG data for interpreting and further processing or further decision making. So, that is very important. Here a very new emerging field is that neuroergonomics. What it does, EEG which is primary requirement for this particular field, what it does is it studies the behavioral aspect of a semi-automated system, which is brain computer interaction. Okay. So, brain computer interface we rather call. So, this neuroergonomics is very challenging field, and EEG is one of the best instrument or best tool we can say for this particular field, and we can utilize it for further recording or interpreting the data. So, we completed EMG, ECG and EEG. Now, let us go for going further, let us understand some limitation of this EEG. It is very special, so its special solution is very less. You will get more sensitive recording if you do fMRI, PET and all, but of course, these are very expensive. deeper structure of your brain may not contribute to this particular EEG wave. So, you may not get proper understanding of it. So, that is one limitation, and meninges and CSF may smear the EEG signal by obscuring the its interactional intercranial those transaction, like when these intracranial sources are giving the potential, it may not get reflected properly. So, there may be some obstruction. So, that these are the kind of limitation we have when we are using EEG, but anyway still we have lot of scope to use EEG and get proper information of it. Okay. So, I always encourage to, if you have the context to use of EEG, you please collect use it, and you have more objective value for interpreting your result. So, that is very important. So, once we complete all these electrical potential recording, let us go let us try to understand one more important or frequently used method for ergonomic analysis and product design, that is eye tracking system. Okay. So, tracking the eye movement or tracking how the human being is looking at the object and taking decision or interpreting that particular perception, the perception identification, all those things is depending on the it can be evaluated by this particular system. So, again it is an non-invasive system. It follows mainly three principles. One is photography and the light reflected from the cornea. Second is video based corneal reflection eye tracking system, and third is unobtrusive camera based system. So, these are the three principles we use, and we have three very specific technique. One is video oculography, video based infrared pupil corneal reflection, and electrooculography. So, I will be describing all these separately. So, let us take first the video based tracking. So, what it does? So, a video based eye tracking system can be either a remote or head mounted configuration. It can be wireless also. So, components of this particular setup, whatever we have is a video camera that records the movement of the eye, and a computer that saves and analyzes the gaze data. So, when you are looking at some particular object, that camera is going to record my eye movement, and it is going to transfer to the computer, and it is going to record it, save it, and further analyze it. In remote system, the camera is typically based at the below of the computer screen sometimes, but it's then become stationary. Okay. So, you may not get the data when the person is in dynamic condition, whereas you have some system which is head mounted. So, that the camera is attached either on a eyeglass. So, you are wearing a goggles and the camera is fitted over here, or some kind of helmet you have, and you are actually recording the eye movement. So, that type of systems are available. We have one of them. I will show in the laboratory how we are doing the experiments with the eye tracking system. In IR's PCR tracking system, what we do? System is very much dependent on the visible light and pupil center tracking that tend to be inaccurate and affected by the head movement. Okay. So, there may be a problem. So, to address this, a reference point we can add, that is the corneal reflection, and we call it glint. Okay. So, it is added by using an artificial infrared light source and aimed at on or off axis the angle. So, when on axis light source will be there, it will bright the pupil effect. This will make easy to recognize the pupil in the image wherever it is possible for that particular software to analyze it, whereas off axis light results in the dark pupil. So, if it is on, then it is bright pupil, and if it is off, then it is dark pupil. So, both these parameters help in keeping the eye area well lit, like the whole eye will be very much in light, but it will not affect the human sight, because IR cannot affect the human sight. Okay. So, but again use of IR again in a question. So, whenever we are using it, we have to be very careful. Now, we have electrooculography, we had videooculography, here we are talking about electrooculography. So, it is again the changes in the polarization. So, the human eye, we have the dipole with positive pole at the cornea and its negative pole in the retina. So, this cornea retinal potential difference, if we can measure, then we will be able to understand how the movement is happening. So, when there is a origin of the at the steady electrical field will be there, and electrical signal that we can measure from this particular like retinal and corneal, we will be calling at the electrooculogram. So, how we are going to measure it? Now, take an example. Okay. So, we place two pairs of surface electrode, because we really cannot do intravenous thing. So, we are placing surface electrode in periorbital position around the eye with respect to our reference electrode. Okay. If the eyes move from the center position, like suppose I am looking at here. Now, if my eyes, look at my eyes, if my eyes are moving on this direction, then what will happen? Towards this electrode, that retina approaches this electrode, whereas cornea approaches to the opposite one. So, this changes, this particular difference we will be able to record and then further measure, and then we will try to understand how the changes happen, how long that changes happen, and from where to where these changes happen. Okay. So, this way we actually measure the we use electrooculography. In our laboratory, we have the first one, I will show you during the lab experiment. So, when we are talking about eye tracking, we have gaze replace, heat maps and gaze plots. These are the three major identified variables that we are going to use, or identified nature that we are going to use for interpreting the data. So, let us understand what is gaze replace. So, gaze replace enable watching the test session video with users eye motion overlaid over a recording of the changing computer screen image. So, when the screen image is changing, how it is moving, so that you need to see. So, if a particular blue dot will be there, which will continuously move on the screen, and if the particular person is looking at first here, then here, then here, and then somewhere in the screen, we will be able to see that blue dot is moving. So, how long that dot is holding where, and all those things we will be able to map it. So, gaze replays are very interesting to observe, because it really shows how my eyes are moving in the screen. Also, it helps to understand my path, gaze path, like from where to where I am moving, I means the subject is moving. So, that is very important, but yes, this particular process is time consuming. You should be very careful before planning this particular experimental setup or experimental study. Then gaze plots. So, here we have user's fixation, position of the user's fixation, numbers in the dots depicting the order in which users look at the item, and the size of the dot denoting the duration of the fixation. So, if the dot size is larger, that means you looked at the particular portion for longer duration. If it is less or diameter is less, you have looked at for less amount of time. So, this way also gaze plot we call it, through that also we can understand how my eye tracking or eye movement is happening. Okay. The third one is the heat map. So, here as the nomenclature says heat map. So, if I am looking at that particular object, it will look the portion the location will denoted by the red color, whereas when you are looking at for that particular place for lesser duration, it will be as a blue color. Blue means cold, red means hot. Okay. So, that way you can identify in the, on the screen or on the product or on the shelf or on the display image where the person is looking, how long, what is the concentration and all those things. Here it is very important, suppose I am looking at particular object and thinking something. So, how do I identify that? So, or I am looking at particular object like physically, but really I am not mentally present in that particular place. So, how do I understand that? So, here integration of different system is very important, especially if you integrate eye tracking and EEG, then it will be very good to interpret the whole context properly. So, many times it happen that user is particularly talking about something and thinking something else, or there are lot of dynamic elements on the page. So, how to interpret that? Maybe there is a page is being evaluated alone and does not involve the user's recall. Okay. So, how you are going to evaluate all these things? There you may have some misinterpretation of your data and you should be very careful. So, whenever you are using eye tracking system, before collection of the data, you first prepare the experimental setup, try to understand what are the clauses are involved for this particular situation, try to understand the context properly and then do some trial and then only start your actual data collection. That is the best option if you want to get a proper and nice result out of your experiments. So, this is very important. As I mentioned earlier that color coding like for this heat map, that red is hot, that means you are looking at that particular portion for longer hours, very intensive looking, whereas the other one is cold where you are not looking for longer hours or it is not least viewed area. So, how this particular method is helpful in the field of ergonomics? Suppose you are designing a workplace or you are trying to set up an workplace, how the person is going to interact with those elements of the system and how those elements has an influence on the worker's performance, you can really monitor or really understand or take a pre-measure using this eye tracking system. So, eye tracking system also helps for the cognitive ergonomics because it helps to understand the perception of that particular product if it is integrated mainly with the EEG system. Okay. So, that helps a lot. Also, eye tracking hardware has been evolved. If you see our instrument, you can see lot of improvement from the earlier one. Nowadays all these wireless technologies are involved. So, if you have those instruments, you really can monitor. In case of design, of course, how that design has an impact on the user, you can really measure it, especially in case of merchandising. It is very important, display design, then in the galleries and all, you really need to know how the eye movements are happening, how the color, how light has an impact on the gazing and all those things. So, this type of study is very dependent on the eye tracking system. So, again I would like to refer, these are the books through which you can study all the things whatever we discussed today, and if you have any query or any question, basically because these are very technical in nature, whatever we studied today and last class, very technical in nature. So, understanding, detailing is very important. Okay. So, you read it, try to practice it. If you have the facility available, or you try to contact your nearby institute where this type of facility is available, at least you try at least one experiment, and then let us know your constraint, or let us know how you are interpreting your data. So, what you can do, you take example to create your own context and collect your data accordingly and share those interpreted result with us, so that we can understand you have understood correctly or not. Till then, thank you.